to our lesson today. I just wanted to share a little something with you in case you've never thought about it before. Right, you could call this, I'll share a variety throughout the year, but Mrs. Alviso's Chemistry is Life lessons, right, because chemistry is life. Does anyone know on a scientific level how muscles grow? Like how to get stronger muscles, what happens? Kesley, there it is.
They like tear, and then they like get back together stronger.
Yeah, so to actually get stronger, your muscles, fibers, literally have to tear. That's why you get sore when you're building muscles, is because you're literally tearing them. Then the new proteins come in. Sorry, so here's your muscle before. Tear it. New proteins come in, fill in the space, and now you have a bigger muscle, right? So the process of growing can be painful. And I think the same thing in some ways can apply to brain growth. Now our brain is not a muscle, but as we've learned, it is pliable and it grows. So I just want to throw out there that if any time throughout this whole year, your brain is hurting with what we're doing, it doesn't mean you're doing it wrong. In my opinion, that just means you're actually doing it right because you're trying to grow. If it never hurts, then you're not challenging yourself enough, right? Like you're never going to get growth if you don't challenge yourself. So just so you know, if you've ever had between the few days we've started, but you've had moments where you're like, oh, this is so hard, recognize it's hard, but also recognize it's okay. It's okay for things to be hard. It doesn't mean something's wrong with you or the process. It just means keep moving forward. And when it gets to a point that it feels too hard, come see me. I had one student there's a few who came in during Sky Time today, but one of them in particular was very confused when he started at Sky Time. We talked for 5 minutes, and then all of a sudden, something clicked, and he was able to finish his homework, right? That's what I'm here for. It's good to struggle, but if you get to a point in your struggle that's not productive, meaning I'm not moving forward in my struggle, come see me and get the help, because that's what I'm here for. I never have anything during Sky Time. I don't do any clubs or anything else. Sky Time is just for you guys to come get help. And fun fact, I don't have a second period, so my Sky Time's really empty, because I don't have random kids that just didn't sign up to go anywhere else, because it's my prep period. So if you come, there was maybe like, what, Crystal, like 10 of you in here today? Yeah. Right? So like, and it's totally too, like, Ben came today and he didn't know if he had questions, but he's like, well, I'm going to work on my homework, right? Like you can use my Sky Time for that as well, okay? Other great times, I'm always here before school by 7:15 at the latest. Mornings are pretty quiet. No, people don't come in, so if you ever want to come, ask questions then. And then I'm also here after school till 3:15 almost every day. So not A days. Oh no, today is A day. Not B days. But on the days I'm here, please come see me. And even lunchtime, if I don't have a meeting, you're welcome to stay after class and ask me your questions. So, all right, today we're going to recap some of these, and it's going to lead us into our new objective here of empirical formulas. Okay, so let's take a look at number 2. This is actually in your notes, so everyone turn to your notes where we left off last time. Being sneaky here, we're doing double duty. This is the exact question we didn't do last time, and I just wanted to see where we're at in figuring this out. Okay. All right, so our question here is, how many atoms are in, I added more sig figs to mine because I only gave you one, and that's so dumb. One sig fig is annoying. So I changed it to 3.00 on the quiz, but on your notes it just says 3 grams, okay? We're looking at how many grams. Remember, underline what you know, right? Guess method, start with the given. Circle what you're trying to find. Okay? Now I'm going to draw a little picture. You have it in your notes, so you don't need to draw this. But this is what I call the roadmap. Is grams on this side for you guys?
Yeah.
I just want to make it the same as your picture. This is what I call the roadmap of conversions. Okay? If you are feeling confused right now on the homework, use the map. Eventually, if you travel enough time somewhere, you don't have to use the map anymore, right? Hopefully. Okay? So, but right now, if you're like, I don't know where to go to the map. Okay? In our problem, where am I starting? Grams. So I am in the land of the gram. Okay? We're going on a journey. Where do I want to go? I want to get to here. Okay? So, start with what's given first. I'm going to write I guess I won't write the zeros because you don't have 3 grams of copper. Start with what's given. If you're like, I have no one else to do, at least start with what's given. Then, set up your conversion. The reason why I don't close off my bracket, by the way, is I just don't know how far I'm going to write yet, and I don't want to be squished. So that's why I like leave it open-ended until I'm done writing. Okay? Our pattern is, every time, whatever unit is here, copy, paste. Grams of copper. Alright, I'm going to keep going with our units, because units to me will guide the way. Alright? Now, coming to my map, I want to get here, but there's no airplanes in this place. You have to take the road. So before I can get to particle, I must first go to mole. That's where the phrase, when in doubt, mole it out. Everything connects to mole. So if you're not in moles, you got to get to moles. Okay? So I'm going to put mole of copper on top. Oop. And I close my bracket. Okay? All right, next step. Notice, because I want to get all the way to here, that's how I know it's going to be 1, 2 steps. If I was stopping at mole, it'd only be 1 step. All right, copy, paste. Mole, CU. And then I want to change it into particles, atoms, that family of things, right? So I'm going to put atom of CU. Say that one more time, Emily. I don't know if A is technically a symbol for anything, but I'd probably write atom. But okay, questions so far on my setup? Do you guys see how the colors are working in a diagonal way? What's the only color that doesn't cancel diagonally? Which is what I want. So I don't want it to cancel because I want that answer. Okay, once I have all of that, now I go back and do my numbers. Okay? So, this is an independent statement. It doesn't matter what comes after, it doesn't matter what comes before, it's just a true statement connecting those two things to each other. So whenever you want to connect gram to mole, it's always connected through. If you want to add this to your math though, that's when you use the molar mass, because that's what connects those things together. So I go to my handy dandy periodic table. Copper has a mass of 63.54, what did yours say? 546, okay. Now, is that how many grams of copper or how many moles of copper?
Grams.
Yeah, right, that's where make it, I just wrote what I said. Right, I can turn this fraction into a sentence and it makes sense. 1 mole of copper equals this many grams of copper, right? Like that little bar of copper I had last time was 1 mole and it weighs this many grams. Yes, Emily?
Is the molar mass always like the atomic weight of the periodic table if it's not a compound molecule?
Yes, and if it's a compound molecule, it's
If you
different.
add
There you go. Yeah, good reminder. Okay. Questions on this step? All right, this one is connecting moles to atoms. So whenever you're traveling this road, that's when we use Avogadro's number, 6.02 times 10 to the 23rd. Now, where it goes determines where it makes sense based on the units. That's why if the units are already there, I can see, oh, this should go on the top because there are this many atoms in 1 mole. There's not that many moles in 1 atom. Once again, the idea is the more you can take this triangle, right, and see the full picture of what it's saying, it will make a lot more sense, and it doesn't feel like memorizing, does it go on the top or does it go on the bottom? It kind of depends on which way you're going, right? There's not a set pathway. But there is a set pattern that always happens. All right, when I plug that into my calculator, what did I get? Oh, you want me to show you that? Good question, Molly. So the way I would type this into my calculator, where should I write this? Over here? Okay. All right, so my calculator, so left to right, so I would do 3. This is on the bottom of my first fraction, so I would divide 63.546. You could type this in as a fraction. You could do 3, parenthesis, 1 over that, close parenthesis, but to me that's just a lot more typing than just hitting divide. So anything that's the number 1, I just ignore. Since this number is on top, I'm then going to times 6.02 to the 23rd.
So could you also write it like 3 grams copper times 6.02
Is
over 6.3.
wouldn't that just be
Say that one more time, Emily.
So like could you do like 3 grams of copper like
Get the right answer.
like how we're showing how to
Wait, I wrote like 2.8. I just like, cause I
Yeah,
rounded
but
it.
just a sig fig, because there's only
just
one
round
sig
it.
fig in it.
I think let me see what I think are you saying like, could this have been over that? Mathematically, yes, it is the same thing. But conceptually, that sentence
I got like
is
2.8, but I
confusing to
rounded
try to skip from gram to particle without addressing the mole value. But mathematically, yes, it is the same because those ones are doing that. But you should, yes, that's where it wouldn't work. So yeah, always do it in 2, even though right now because eventually there's going to be times where this isn't a 1 anymore next to mole. Right now it's always a 1. Yeah, good question. Any other questions on this setup before I have you try one?
6.02 times 10 to the 23rd.
So, yeah, so the answer is this many atoms of copper.
Changes
And
how
then
many
can we
moles.
just use the same formula for like if we ask for
The
grams?
conversion
How
for
do you
that
do that
is
conversion?
Like when it asks for how
So-
many grams that are used in one mole, same,
It's not so much, I wouldn't call it the same formula, but the same pattern is always true. Where if you always have your diagonals, right, whatever that diagonal needs to be, and then you make sure to put the right number next to it, it will always work out.
But how do you know which diagonal is supposed to go where?
Because whatever was here, copy paste.
That's the cancel.
And the bottom, another way you can think about, it's kind of a funny way of seeing it, but if you're thinking it like traveling on a road, the bottom is always where you're leaving, the top is where you're going. So I was in the land of grams, and I first had to go to the land of moles. So I left grams, went to moles. Then I left moles and went to particles. So the top is where I'm going, the bottom is where I'm leaving. Is that a little bit? Okay, I'm gonna give you guys, let's do 4 minutes, and I want you to try that last practice problem, see if we can get this set or answer any questions that you have, okay? Ready, set, question?
So the practice problem here or the last
That one, the one in your notes.
Okay.
Yeah, well, I don't even remember what it says, but do the one in your
So
notes
which number do we put in?
to practice another 2-step.
Wait, what?
Oh no, what cut you? How did it cut you? Oh, and like you just reached it.
You put the 5.4. No.
of the thing.
One bulk basically the centerpiece, so we're dictating everything around one bulk. That-
So 18.01. No, I don't think that goes down there because that's the mass, not the molecules. Because like that's the mass. Yeah, but that was, we were trying to get into atoms. Now we have the molecules, we wanna know how many grams are in it. So we're going opposite, we're going number of particles to grams.
Yeah.
Do you guys get one sig? What did you put underneath the first fraction? 6.02. 6.02 times 10 to the third. Because right here we have molecules, so then we how to get rid of molecules. Because like you know on a fraction, if I have like a fraction and I do like multiply, like these two cancel out.
Yeah.
And then it's 8 over 5.
That makes
So that's how it works. The molecules cancel out and then the moles cancel out. I don't know. That's how I remember it.
So what if for the first, the 5.4 times 10 to the 24th times divided by what? The 6.2.
Yeah. Divided by the 6.2. When I type it in my calculator, though, I do everything on top multiplied first. So I put 5.4 times 10 to the 24th times 18.02 divided by 6.2. Oh my gosh. That is so complicated. You times everything on the top, divide it on the bottom.
Did you just add it or did you? So like did you do 5.4 times 10 to the 24 times 18.015 divided by, or would you just
Put divided by 6.02. Yeah. And then do you round it to just 1/6?
Wait, what'd you get?
What do we round it
How many sig fees did I get down?
to?
But you can't write it out.
Wait, so then we just round it to 1/6.
Oh yeah, so round that to what? 1/2 number.
What's 160?
Because you
Like
get
161.5.
Wait. I took the ones I got like
1. It's just gonna appear.
And I have to put parentheses in mine.
How did you figure that out? I could not figure this out on the quiz. Yeah, I couldn't figure it out. I had to ask you for another one. And then divide it by
divided by 6.02.
Thank you. All right, with rounding for sig figs, you should have gotten 160 grams of water. If you got that, give yourself a smiley face. If you didn't get it, it's okay. We're going to get there eventually, okay? Today's lesson is something different, but we are going to be doing conversions along with it. So we'll get more practice with it. And then, of course, come see me if you need more help. Yes, Emma?
How do you know how much?
Good. Oh, look at it. It's not. It's just go to what they gave you. Since I only gave you 5.4, that's 2 sig figs. So my answer only got 2 sig figs.
But if you're ever calculating
Does that
the
make
molar
sense?
mass, do you have to find the molar mass thing of the fig, and then if that sig fig is less than like
It wouldn't.
I would
It
say
wouldn't.
no. Just focus on what is given. I will say this though, Emma, you bring up a good point. What did it get on your calculator? I don't remember my original answer.
That's
Without rounding.
Oh, it's like just off. That's the same. That's the right number though. but
Yeah,
it's just
like I just
That's
don't know how to like, cause you know how,
Okay,
Just
I'm
a
gonna say
weird
this, everybody.
calculator.
cause you know how she has like the triangle.
As of right now, I care more about your, like, you're doing the process correct than rounding for sig figs. When it comes down to it, sig figs are something we're always gonna be doing, but they're graded this much on the AP exam. So I'm gonna change what I just said. If you got an answer of 161 and you didn't round for sig figs, but you have that answer within that range, you can have a smiley face because you did it right. I don't want you to think just because you rounded wrong for sig figs, you're doing the whole process wrong, which is the big picture. Okay? All right. Our third question up here that I want to address. So this says, write a sentence explaining what you would do if I gave you magnesium and told you to measure it out in 0.34 moles. Okay? Anyone willing to share with us what they wrote on that? Okay. Okay, everyone listen to Calder here. Calder, I'm giving you this magnesium. Go into the lab. Give me 0.34. What are you going to do?
You could measure the grams of it and then like use the formula to find out the moles that's in that and then divide that by 0.34, then find like that fraction of it. Yeah.
Good. How was my face? So, summarizing what he said, okay, moles, we talk in moles, we use moles, but you can't directly measure in a mole. There's not, like, it's a counting unit, right? I can't just put it on a scale because that's going to give me a mass. I can't pour it into a beaker, that's going to give me a volume, right? It's a counting unit, but it's not like a dozen where I can actually count to 12, right? So you have to, in order to get a measurement of moles, you have to first convert it to grams, right? So you have to figure out, okay, well, how many grams is 0.34 moles? Then you can easily go weigh this out. Yes, Emily?
Yeah, so I was just gonna say that I would have found the molar mass in copper, and then I would have multiplied 0.34 to the ratio of the molar mass over 1 mole.
Perfect, and then that would tell you how many grams to measure on the scale, okay? So as we're looking at this idea, today we're going to be learning about these things called empirical formulas. When atoms react and turn into molecules, some molecules have a set ratio they will always be. If sodium is reacted with chlorine, it always reacts in a 1-to-1 NaCl. There's no such molecule that is 2 NAs and 1 Cl, or 1 Na and 2 Cls. It just does not exist. But a lot of other things can react in a wide variety of ratios, right? Particularly all of your organic molecules, carbon, hydrogen, oxygen. There's like an infinite number that I can even think of all the different things that are made from just those 3. Okay? Now, just to review in case you're unfamiliar, okay, and then I'll do my little demo here. Just some words, and once again, in case you're not familiar with it. When I look at a formula, let's go with water. Okay? The small number down below is called a subscript. Okay, so just a word I realized I was using but I never defined in case you didn't know it. A subscript is a small number below, and it indicates a chemical bond between those things. There's a difference between writing this in chemistry and writing this. A subscript only impacts the thing it's connected to. A number in front is called a coefficient, and it is a grouping number. It's saying you have 2 sets of that whole thing. Kind of similar to like our parentheses idea, but the parentheses aren't needed when the number's in front. We just know it applies to this. Okay? Yeah.
Look at like parentheses around the HO and then like a subscript outside the parentheses.
So I'm trying to visualize what you're saying, Cohen. Like this?
Yeah, and then a subscript on the outside of the parentheses.
Like that?
Yeah. Would it do anything or just no?
So with this 2 out front still?
No.
Or like without that? So technically this has different meaning than this, yeah? Because this indicates a chemical bond relationship where this is just sets up then. So like, maybe to draw a weird picture, it doesn't actually exist, right? But we can use water as an example. So like if I have 2 here, then that means I have 2 separate water molecules. But if hypothetically it was like this, then all these things would actually be like chemically bonded to each other. So does that make sense, the difference?
Yeah.
Yeah, good question. I missed my face for that. Okay? So as we're looking at this idea of formulas and ratios, there's a type of formula known as an empirical formula, which is the smallest ratio of it. Key thing to recognize here is an empirical is just a ratio. It is not what the substance is. But by understanding the ratio, knowing it's a 1 to 1 or 1 to 2 or whatever, it can help you understand what the actual substance is, which is the molecular formula. Okay? All right, little demo here just to try to bring chemistry to life. Okay? So I have some magnesium, as we saw, so this is Mg. Okay, so once again, this is your first experience of thinking all sides of our triangle a little bit. Okay? So we see with our eyes, solid metal. Okay, once again, it's very pliable. I can bend it, break it really easy. Okay, I'm going to react it with oxygen. Now this one, can I see the oxygen with my eyes? No, because it's a gas, right? So the oxygen I'm using is just what's in the air, right? Okay, we are going to chemically bond them together to create something known as magnesium oxide. The big takeaway here that I want you to recognize is the identities before and the identity after. Okay, so before we have this and this and there, okay? And then after, what's going to happen? Okay, now this is going to take way too long if we let it happen on its own. So we'll learn sometimes in chemistry we do things to speed things up because it would take like 10 years for this to react. No one has time for that. Okay? So I'm going to use heat as a source to speed it up. But recognize it's not that it wouldn't happen without the heat. It just, we need it to go faster. Yeah. So, what was that? Pretty much. We're making it rust very quickly. Okay, now with this one, there are some, without giving away, but also trying to protect you for safety reasons, I'm going to hold it right here, okay? Don't look at it directly. So like, okay, I'll put it right here. So here's my circle, but you can look here, and you can look there. Just don't look right at it. Okay? I know, now you want to, but I warned you, so...
What'll happen? Like, wait,
It's just... Yeah, it's just like, you know, it's just like how you should stare right at the sun, right? But like, you can look right next to it. Yes, go ahead.
So if I do it, will it like damage my eyes, or like is it not bad enough where like I can do it?
I just have to say the warning.
Okay, I'm gonna.
No, nobody's gonna. Okay, are we ready? I'm scared. Don't be scared. It's fine. Just don't look right at that.
I'm looking.
Oh wow, that's like welding.
Yeah, it's really red eye. Some of you are burning your retinas right now. I can see that.
Oh, it hurts.
This hurts my
Jack.
eyes.
Okay. Still got it. Some fell on the ground.
Like if I close my eyes, I can see.
But I'm going to come around so you get a closer look, and I want you to notice the after. Okay, remember what you saw before, and now what it looks like. Get that smell out. So this white powder is our new substance.
I'm so sorry.
We have 30 minutes.
Yeah, the one that's in just didn't get burned.
Oh, 25 minutes. So you have 25 more minutes of your video, okay? You're almost through it, but at least you can watch it on double speed.
So that was like the
I
smoke that
get
was
double
coming out.
speed through class, so you're the lucky ones. No, they're working smarter. They can watch us on double speed. We have to just sit here. Like their video is only 10 more minutes long, but our video is 20 minutes. I'll probably skip them through this part right now.
All right, so this takeaway once again is like a theme of chemistry you should always understand all year long. Okay? Our end result, does it resemble any similarity to the themes prior?
No.
No, right? Before we had a solid, I mean it's solid, I guess that maybe, but we had a metal and a gas, and now we have a white powder, right? When things combine chemically, they change their identity. It's not like they have little pieces of what they were before. They're things that are completely different, okay? It's crazy in that something that is vital to your survival, water, is composed up of two things that are both very explosive. But then we use water to put out
Cool.
explosives, right? Like, so that's just something as we go through the year, recognize that that chemical combination changes what they are, okay? All right, let's look at some examples. Yeah, Isaac.
So in the reaction, did it turn into a gas and then kind of crystallize on the tongs, or did it like directly powder?
It's just powder, yeah. So there's a big pile of it on my floor right here
Oh.
that like most of it fell off.
What do we
Sometimes it will
write?
actually kind of hold its shape a little bit,
I
but
saw it like
very
flames, like
fragile.
fall
Yeah.
down.
Oh, I went too far. Hold on.
Oh
Go
yeah,
back.
this is slag. It's
I feel like because I'm like leaning forward.
It's lagging. Whoa, it's going back.
unknown substance.
I wonder if they can see.
It's like combining two and
They
oh,
can definitely see me.
catch up.
Can they like
Okay,
see us
they
if we're like
see-
leaning like that?
Here's some examples
They see me
that I
now.
want to
Don't be
address to
lying with
understand
me,
the
bro.
See the top of
definition.
your head.
And then our goal is to learn, we're going to learn how to calculate them. Okay? So here's an example of an empirical formula. Pay your attention up here, everybody. Because it is the smallest ratio it can be. Right? 1 to 1 can't be reduced. Another side note, we don't write number ones as subscripts, just like you don't write 1x. If you want to do it, there's nothing wrong with it. Just you're never going to see one written that way. Okay? This is an example of a molecular that reduces to that empirical. Right? C2H4O2. Two things to recognize here, once again, is empirical formulas are helpful as a step to get to the molecular. We want to know what an unknown is. But that's it. They are just a step. Knowing them on their own doesn't really actually tell you what it is at all, because there are a variety of ratios it could be. Great example. This right here is the chemical formula for vinegar. Okay? This is the chemical formula for formaldehyde. Formaldehyde is not vinegar. 2 tablespoons of this and you'll die. Right?
Is that fentanyl?
What's fentanyl look like?
Formaldehyde, it's the stuff they soak like dissections in.
It's
Like
like
that strong
raw.
Like all the toxic chemicals that you could be introducing to drugs, like formaldehyde, which she then thinks about, because it's the same chemical your uncle uses to preserve this weird smelling taxidermy like cat.
I don't think you actually.
Wow.
What's the
I've heard it
molecular
all.
formula?
Wait,
What does it look like?
Spotify ads where it's
Yeah,
like,
it's a Spotify
where it's
ad.
like you could be
The
making
molecule
sure
above is not that, but it's a
I know. And then there's this bad
What about methyl? What about methyl?
I heard.
Okay, Okay, ice back in front.
Alright, what's next?
Okay, so if you're given a molecular, to go to the empirical, you just reduce them as much. So C6H6 would be just CH. But another great example, this is a real substance. This is called benzene. It exists. It's a substance used for stuff. This doesn't even exist. There's no molecule, just C and H. It doesn't happen. Okay? So recognize that empiricals are just a step to help us get to the molecular. On that note, I can go easily from here to here, but to go from here to here, I need more data. Because it could be P4O10. It could be what else do you want to do? P6O12.
Wait.
12.
Okay.
O15. Right? Like, it could be hundreds. It could be P200, O500. Right? All of these reduce to that.
Oh yeah.
So knowing which one it is, that's what we're going to figure out now. Okay?
Do you just write one?
All right. As we're solving, as you've maybe seen our pattern, as we're solving this problem, I'm going to walk you through this first one. I'm going to be using different colors to help indicate the different steps. So I highly recommend you do that as well to help you remember, like, okay, this was my step 1, this was my step 2, so on and so forth. Okay? After we do this one, then as always, then I'll have you guys try one and see how we're doing. Okay? All right, so our question is, we have a substance, we know these percentages. By the way, these percentages come from a mass spectrometer. So this is where a mass spec can be used to determine not just isotopes, okay? But we're never going to look at those graphs, but the data can be given to you, okay? Our goal is to figure out what is the empirical formula for this substance, okay? So our step number 1, I don't want to do black. Okay, I'm going to do step 1 in this purplish color. Okay, so step number 1 is we are going to assume 100 grams. With kind of a side note of if not in grams. If you're already in grams, you don't need to do this. And I'll show you what I mean. Okay? In the end, we're trying to figure out the subscripts, right? So our end goal to keep us in mind is we know we have CHO, and we want to know what are these subscripts. So our first step is we've got to get to convert to a ratio of figuring out what these are. Yes, Ben?
Where'd you get the carbon from?
Oh,
40.92%.
that's supposed to say carbon. It disappeared. Is it on your paper or is it gone too?
No.
That's the mystery. Substance right there.
It's gone. It's supposed to be carbon. Thanks, Ben.
Carbon despawn.
Show.
Okay? Alright, so the reason why we're going to assume 100, everybody. Alright, give me your focus here.
Carbon rate quit.
Okay? Is that because they're percentages, if I assume 100, then I can just change it straight to grams. So my first step is to say, alright, I have 40, ooh, this one's not very vibrant. We have 40.92 grams of carbon. I'm going to list these down, but give yourself space in between because we're going to convert each. So don't write them too close. Okay, we're going to have 4.58 grams of hydrogen and 54.50 grams of oxygen. Step 1, put them in grams if they're not already there. They could be. There could be a problem where instead of percentages, it just gave you grams already. In that case, you're already there. Okay? All right, step 2 is we need to convert each of these values into moles. So step 2 is convert to moles. Because when I look at a formula, subscripts are a ratio of actual particles, not by mass. So I need to know by 1 to 1, where do we sit, okay? So I know my grams, and I want to convert into moles. So I'm going to set up my conversion fraction, as we just did before. Grams of carbon is here, so grams of carbon will go on the bottom, and mole of carbon will go on the top. Okay, so we look at the periodic table, 12.011 to 1. So this came from the periodic table, found carbon. Okay, when I plugged that in, I got an answer of 3.407. I can't remember if I said this last time, but as I'm doing problems on the board, I would encourage you not to worry about typing it in your calculator and just focus on the process. Okay, because sometimes you get caught up in typing something and then you miss the next step. Okay? All right, let's label that. Moles of C. So now we gotta do that for each piece. So I have my hydrogen here. I'm gonna convert it into moles of hydrogen. Thanks, Isaac. So 1 mole of hydrogen is 1.008. Plug that in, and I got 4.54.
Or 1.00795.
Yeah, I used the ones on your periodic table when I did it this morning, just so that it's the same as where you looked. Okay, oxygen, same thing. Go to grams to mole. And I got 3.406. Questions on step 2? All right, step 3. We now want to create a ratio, and so we're going to divide by whichever value is the smallest. Okay, so we're going to divide all values by the smallest moles to create a ratio of 1 to something. Now we have 2 that are very close, but which one is the actual smallest? Oxygen. Right, so 3.406 is the smallest of these. So I'm going to divide all of them by that same number. Plug that into my calculator, and this ends up being 1.000. This one ends up being 1.33. And this one ends up being 1. Add my labels on there just to remember. So this is moles of O, moles of H, moles of C. Green. Now we could be done at this step because we have our ratio. The problem is it needs to be a whole number ratio, not a 1 to 1.33 and 1 ratio, right? Like we don't write 1.331 as our subscripts. If these turned out to be whole numbers, you'd be done. So this is like if needed step, okay? So if needed, we're going to multiply to get whole number. So the way to figure out what to multiply it by is you think of the decimal like in terms of a fraction. So 0.33 as a fraction would be
1/3.
1/3. So I'm going to times everything, because we don't want to change the ratio, we just want a whole number. So everything gets times by 3. If it was a 0.5, then I'd want to times everything by 2. Yes, Emma?
What if there were 2 decimals?
Great question. There shouldn't be. Well, there could be, but they would both be able to work the same. So like we could have another one that was maybe like 0.666, because that would be also within the third grouping. But if you had 2 that were very different, then I'd probably backtrack and check my math. So yeah, great question, Emma. Have a smiley face for that. Okay, so that ends up giving us, this is 3, 4, 3. And so our empirical formula is C3H4O3. And that's my answer. Yes, go on.
Why are you multiplying by 3?
Because my ratio was in orange, right? But it needs to be a whole number. And so to change this one that's not a whole number into a whole number, we multiply it by, because think of it, since it's a third of a fraction, if I times it by 3, it's going to make it a whole number. You see that? Yes, Emily, then Isaac.
I guess with the sig figs, how come the one where it's like exactly 1.000 has the 3 zeros, but the one that's like slightly off has the zeros, and like
Because
do you need the sig figs or
it doesn't really matter once you get to this phase, because we're going to get a whole number in the end. So I just wrote them there to recognize, like, I know it's not exactly 1, but if you plugged it in, this is actually what you get, and then the next number is like 2 or something like that. So yeah, sig figs in this case, keep them throughout, because if you round too early, it can actually really mess up your ratios. But then once you get to the whole number, we're just searching for that whole number ratio. So, Isaac, what was your question?
So like, what if like the top number was like, couldn't be so easily multiplied? Like, what if it was like 1.018?
If it's ever like, because so sometimes, and I think our next one we'll do is it ends up being not exactly 1, but it's like 1.0 something, you can just round it to 1. Yeah, so it's only if it's like, here's kind of the options you would see, is if it's like, you're gonna put this down, so if you see a 0.3 or 0.6, then that's gonna get multiplied by 3. If you have something close to 0.5, then you would multiply by 2. And outside of that, we really won't come across it in this class. So, which if you do, if something's like really weird, then I'd maybe backtrack. But you might find, I think in one of the ones on the homework, this ends up being like 1.99. You can just call that 2. And you don't have to multiply that to get a whole. So. Okay, now, is that the actual formula of our substance?
No, it's empirical.
Good, so now we gotta do part B to get the actual formula. Okay? So, skipping down to 1.3b, this says the substance was determined experimentally to have a molecular weight of 176. This has to be given to get to the next phase. Otherwise, we're just stuck at the empirical. Okay? All right. Is everyone okay if I erase all this?
yes, I wrote it down.
All right. The first part is honestly the hardest, and then after you have the empirical, it's just one more step. Because all we're trying to figure out is what's the next ratio, right? Is it times by 2, times by 3, times by 10? Right? Next, we're trying to find that ratio. So to find what the ratio is, okay, so our equation we're going to use is to find the whole number ratio. We're going to simply take the molecular weight which has to be given because it's determined experimentally. You can't figure that out without going into a lab. We're then going to divide that by the empirical weight, which we're going to calculate from what we found. The top part should be given, the bottom we're going to find based on the empirical we had before. So just as we did many of times last time and on your homework, we just need to add up this. So I have 3 carbons, 4 hydrogens, and 3 oxygens. So I'm going to find all their masses. So carbon has a mass 12.011. Times that by 3, because of that 3 there. Hydrogen 1.008 times by 4. And oxygen times by 3. Plug all that in, add it up, and I got a mass of 88.062. Questions on finding that mass? That's like what we did last time, but any questions on where those numbers came from? So now, we just take what's given, so up there, so we have 176 over 88.062. Plug that in, and now this is, it needs to be a whole number to multiply it, so this one ends up being 1.99. So my whole number I'm going to multiply would be is 2. Due to just experimental error, it may not come out a perfect whole number, but this one should be really close. If this one was ever like 2.5, then I would backtrack again because something's probably wrong. So, Isaac, did you have a question? You're good. Okay. All right, now I don't circle this. This isn't my answer. What do I do with this 2?
How you put it on?
Yeah, so we're going to multiply the C3H4O3. So my molecular formula is C6H8O6. And that is the actual identity of our unknown substance.
Wow.
What is this?
Acetic acid. Questions?
No.
Okay, we got 6 minutes. Turn the page and let's try this one. It's actually only a part A, so I think we should be able to get it done in these 6 minutes. Try it out with your table group. Let me know if you have questions. I can help you out too.